Hi, I'm Miss Fu. Today we're going to sketch parabolas of the form y equals ax squared. Example 1. Recall from last time that we drew y equals x squared and it looked somewhat like that. Today we're going to change and put numbers in front of x squared and see what happens. So let's say we put 3 in front of x squared. Let's figure out what the y values are. So when x is minus 1 squared is 1 times 3 is 3. When x is 0, we can work out what y is for each of these values. I'm just going to fast forward so you can see. But we notice that the y values are a lot bigger than the y values for x squared. So when we plot these, it looks a lot more narrow. And we also notice that the y-intercept, the x-intercept, the axis of symmetry, and the turning point hasn't changed from x squared. Everything still is the same. The only thing is it's narrow. Now, the a value is 3, or in other words, greater than 1. And we describe this as a dilation. So when it goes big and small, it's called dilation, and it is called narrower when it goes narrower. And we notice that each of the values have been multiplied by 3. So that is the dilation. Example 2. What happens when a, or the value in front of x squared, is less than 1? So let's say we have 0.5. So the y values will be a lot smaller. And our graph will look like that. So a lot wider. So when a, or the value in front of x squared, is less than 1, we say that the graph is wider. What happens if we have a negative graph and we put, say, 3 in front of the negative x squared, so negative 3x squared this time? We will notice that the values, if we plug it into the calculator, we will get bigger negative values. So again, it is narrow. So when we describe negative graphs and we want to look at the dilation, we don't look at the negative, we just look at the number. So the 3 is greater than 1, so we say that it's narrower. Whereas if we had, for instance, a negative 0.5, again, we don't look at the negative, and we can see that this graph will be wider because the value a is less than 1. So we always ignore the negative. The negative makes the graph flip downwards, and the value in front of x is telling us whether it's wider or narrower. So if the value is 3 or 4 or 5, we can see that becomes narrower. If the value is less than 1, it becomes wider. So these are the 4 graphs that we have sketched. So the colorful graph is the graph described, and the black graph is just x squared for comparison. And we can see that the bigger the number, not looking at the negative, so 3 for instance, it's making the graph wider, and the smaller the number, so when it's less than 1, so for example half, the graph is narrower. And we don't look at the negative when we're describing wide or narrow. Last example, which of these equations best represents the graph below? So here we have a narrow positive graph, and here we have a narrow negative graph. So which of these could be describing these graphs? Let's have a look at the equation. This is a negative graph, and 5 is greater than 1, so that is a narrow graph. This is a positive graph, and it's less than 1. A is less than 1, it's a quarter, so it's going to be a wide graph. This is a positive graph, and 5 is greater than 1, so that is a narrow graph. And that is a negative graph, and a quarter means it is a wide graph. So let's get rid of the wide graphs because these are both narrow, and the negative belongs to that graph and the positive belongs to that graph. I hope you've got that correct. That's it from me today. Thank you for watching, and I'll see you next time. Bye!